Hi everybody, welcome to week 4 maths. This is lesson 1 for year 5. All of the lessons for this week are in this one video. So after today's lesson, you can pause it. You can scroll forward if you want to see what's happening in the rest of the week. I thought it might be easier this way rather than having separate videos that you have to kind of find and navigate through. Okay, so let's get started. All right, so our learning intention for today is using written strategies to solve division problems. And the main strategy we're going to be using is the formal algorithm for division, or you might know it as the bus stop method. We're also recording remainders as R equals, as a fraction, or as a decimal, and rounding decimal remainders to a set number of decimal places, for example, rounding to 2 decimal places. And lastly, we're going to be finding related number facts with remainders. Now it sounds like a lot, but actually these first 3 points are things we've done already. So it's kind of like revision. Hopefully you recall recording remainders as R equals, as fractions and as decimals. I thought it would be a good idea to revise that just because we haven't done division in a while. And I know some people had some difficulty with the formal algorithm and recording remainders as decimals. So this is kind of old content at the top here, just refreshing. And the last content point here is new. And it's not really that difficult, actually. It's just a small content point we have to cover. All right, let's get started. So to start off with, let's look at our formal algorithm for division. This is just another way of saying our bus stop method. An algorithm really is a process to achieve an outcome. So let's say we make our bus stop like this. And we put our dividend, which is the number we're dividing, in the bus stop here. And then the divisor, which is 4, goes here. 5 divided by 4 is 1, and I have 1 left over. So I'm going to put it down here to make 16. 16 divided by 4 is 4. Now here I've got 1. I can divide 1 by 4, but I won't get a whole number. I'll get 1/4. So instead, what I'm going to do is I'm going to put a 0 here. And that remaining 1, which is 1 whole, is going to become remainder 1. So it's 140 remainder 1 whole. That 1 whole has got nowhere else to go. Yep. I can't actually split it to make a whole number. So it's going to be on the end, tacked on as a remainder 1. When I'm recording this as a fraction, instead of having a whole number at the end, I still write 140, but instead of keeping it a whole number, I'm going to split it into 1 divided by 4. So I'm splitting that 1 whole into 4 equal parts, one of which is 1/4. So my answer as a fraction is, or remainder as a fraction is 1/4. Let's have a go with B down the bottom. So again, I put my dividend in here, 2,275. That's the number I'm dividing. Doing it in a slightly different order. My bus stop like that. My divisor, which is doing all the work. So I'm going to split this number here, 2,275, into 3 equal parts if I can. So 2 divided by 3, I can't get a whole number, so it's going to become 22. I like to draw a little line there just so I know that I've kind of connected these two. 22 divided by 3 is 7, because 3 times 7 is 21, with 1 remainder. 17 divided by 3 is going to be 5, because 5 times 3 is 15. I have a remainder of 2. 25 divided by 3, well, I know that 3 times 8 is 24. And I'm going to have a remainder of 1, because I've got the difference between 25 and 24 is 1. Yep. And similarly, as a fraction, it's going to be 758. And I'm going to split this 1 into 3 equal parts. So it's going to be 1/3 or 1/3, and that's it as a fraction. Super simple. So if you can record it as a remainder with your fraction, all you need to do is put the remainder at the top and divide it by the divisor, which will give you a fraction like this. Okay, this time around, we're going to be recording the remainder as a decimal. So we're still going to use the same bus stop method. And I'll do this a little bit quicker to start off with. So still the same order, divisors at the front here, dividends here. 5 divided by 4, 1. Make that into 16, 4. Now, here again, it's going to be 0. But because I want to get a decimal answer, I need to put a decimal point here and a decimal point just here. Then I'm going to write a 0 here under the line. And this 1, I'm going to make this into 1/10. Well, actually not 1/10, 10 tenths, I should say. So now, 10 tenths is 1 whole, but here I'm putting it into the tenths column. So I've got 10 tenths. 10 divided by 4 is 2, because 2 times 4 is 8. And I'm going to have 2 left over. So 2 goes there. I need to put another 0 here now. So I've got 20 hundredths. 20 divided by 4 is going to be 5. And I don't need to do any more. So I've got 140.25, which is the same as 101/4, because we know 0.25 is 1/4 of 1, 1/4 of a whole. So that 0.25, 1/4, same thing, just a different way of expressing them. Let's look at B down the bottom. So 2,275. Put our little bus stop on here, divisor at the front. I like to join them like that. 7,152,8. Now here, I do the same thing. I put a decimal point here and a decimal point here. I put a 0 here. And my remainder, so I've got 1 remainder, comes over here. So now I have 10 tenths. Now I'm going to divide that by 3. So 10 tenths divided by, 10 divided by 3, I should say, is 3, because 3 times 3 is 9. And then I put my 1 remainder down here, again a 0. And again, I'm going to get 3 and a 1 and a 3. So this is actually a recurring decimal. So I could keep on doing that forever. It's going to continue on infinitely. So at this point, you can just stop. When you've got a recurring digit like this that keeps repeating itself, you can put a dot on the top like this, or sometimes people put a line as well. Both are acceptable. Yeah, but I know to stop here because I'm just trying to divide 1 by 3, and that's just going to get a number like this. Just like when I try to divide 1 by 6 into a decimal, I just get 0.66666, continuing. All right, so that's as a decimal. So we've used the formal algorithm to do these division problems, and we've represented the remainder in 3 different ways: as a whole remainder, like remainder 1, as a fraction, so splitting that remainder by the divisor, so we've got 1/4 or 1/3, and as a decimal as well. Now, let's look at our quotient, or our answer to a division problem, where it has a remainder as a decimal, and where that decimal keeps on going, either recurring or kind of like what seem to be random numbers here. So this is our quotient from the last question, 758.33333 recurring, and I've been asked to record it to 1 decimal place. Now sometimes you might be asked to record it to 1 decimal place or 2 decimal place. In other situations, you'll need to use your own judgment about, well, am I actually going to record all these 3s across the page, or does it make more sense just to record it to 1 decimal place? In this situation, because the 3 keeps on recurring, it makes sense just to record it to 1 decimal place. If you're dealing with something like money, where we have 100 cents in a dollar, we'd probably round it to 2 decimal places if it's going to be cents. Otherwise, you might be asked to round it to the nearest dollar, the nearest whole number. Okay, so let's have a go with 758.33 recurring. So I'm going to write 758 decimal, and I've got a 3 here, so 3 is less than 5, so it's not going to round up, it's going to stay the same, so it's going to be just a 3, that easy. Oh, and I've lost my decimal place. There we go. 2 decimal places, so that's going to be going into my hundredths here. So I've got a tenths and hundredths. This is me drawing with a mouse. So it's going to be, again, same whole number, 758, decimal place, 3, and it's just going to remain 3 as well. Yeah. Now, if you want to be really tricky with this one, you could actually put a dot on top of the 3 to show that it's recurring. Yeah. And in which case you wouldn't need to record it to 2 decimal places like this. You just do it this way. Let's look at number 2. So 5.285, blah, 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 blah. My whole number here. Points. Now, I want to record it to 1 decimal place. So I'm going to look at these 2 numbers here, my tenths and my hundredths. Now, 8 is larger than 5. So I don't need to worry about any of these numbers here. We can just cut those off. 8 is larger than 5, so it means it's going to round up. So it's going to change this 2 to a 3. And now it's been rounded up to 1 decimal place. If I want to do it to 2 decimal places, then I only need to worry about these numbers here. So I can scratch these ones off. I'm going to look at my thousands, yep, because I'm going to be rounding this hundredths number, the 8. Yep, so I write my whole number, 5.2, and because the 5 is 5, it means it's going to be rounding up, so it's going to change this 8 to a 9, so it's going to be 5.29. And this last one, we've got 5.14. So I want to round it to 1 decimal place. So you only need to worry about these numbers. 5 points. Now, 4 is less than 5, so it's going to round down, in which case this isn't going to change. It's going to stay as a 1. So 5.1. If I want to do hundredths, or to 2 decimal places, I should say, 5 points. So we go here, I need to look at these numbers. Again, 2 is less than 4, or less than 5, so it's not going to change this 4 here. So it's just going to be 5.14. Now, make sure, in a question, it might say round to 2 decimal places. Oh, put an S here because it's a plural. You can just write 5.14. If it doesn't actually tell you how many places you're rounding to, and you decide to round it, you'd need to say rounded to 2 decimal places or rounded to 1 decimal place. That way people know, oh, well, this number keeps on going on, but it's been rounded. Otherwise, they might think that, oh, 5.1, it's a nice, neat answer, but it's actually not telling the full story. It's not telling, well, it actually keeps on going on like this. So you need to specify rounds to 1 decimal place. Now let's look at some related number facts. I've chosen smaller numbers here just to make it a bit simpler. I did try it with large numbers and I almost went crazy. So let's go. 24 divided by 6 is 4. And we know that because we actually know a related number fact as well, which is 6 times 4 is 24, or 4 times 6 is 24. That's because multiplication is the inverse or the opposite of division. So we've got a nice, neat, related number facts going on there. What happens though when we have a remainder of 1 or a remainder of 2, a remainder essentially? Well, I can use this number fact here to help me because I already know that 6 times 4 is 24, but the 25 here is 1 more than 24. So what am I going to do? Well, I'm just going to add 1. Or I could also do 4 times 6 plus 1 is 25. So that's how you do a related number fact when there is a remainder involved. Does it work, however, when the remainders are recorded as a fraction or a decimal? Well, actually it doesn't. The remainder needs to be a whole number, and I'll show you why. So let's go 6 times 4 plus 1/4. My answer is going to be 24 and 1/4. I'd need to have some sort of different number sentence for this to actually make 25, so probably need to multiply this by 4. But this related number fact really only relates to whole number remainders here. But it can be quite useful when you're trying to estimate how much or what your answer is going to be to a division problem where it's not really neat. Now here you know that it's quite simple. You probably don't even need to use the bus stop method here. We know that 24 divided by 6 is 4, and 25 is 1 more than 24, so our remainder is going to be 1. But we can also use it for larger numbers as well. So let's say 163 divided by 4. Well, I know 160 divided by 4 is going to be 40. And 163 is 3 more than 160, so my answer is going to be 40 remainder 3. So I might even write that down. So 163 is the same as 160 plus 3. 160 divided by 4 equals 40. So 163 divided by 4 is going to be 40 is my extra 3 on remainder 3, and there you go. It's actually quite a useful tool or a powerful tool to do that mental division. So just to sum up our main ideas from today, with written strategies, we can record remainders as a whole number remainder, like r equals, as a fraction or as a decimal. If we're recording it as a decimal remainder, and it's a repeating decimal like 0.33333, or it continues beyond 3 decimal places, it's a good idea to consider rounding it to a set number of decimal places, usually 1 decimal place or 2 decimal places. If you're doing that, make sure it's clear how many places it's been rounded to, so you need to write it down, such as rounded to 1 decimal place or rounded to 2 decimal places. And lastly, which is kind of the new thing for today, which is we can record related multiplication number facts for division number sentences with the remainder. So for example, 32 divided by 6, we get 5 remainder 2, and we know that multiplication is the inverse or the opposite of division. So we can say, well, 5 times 6 is 30 plus 2 equals 32. So we're just adding that whole number remainder at the end. It's that simple. All right, guys, I'll see you in lesson 2. Have a good day. Okay, welcome to week 4, lesson 2 for year 5 maths. In today's lesson, we are learning to use calculators to divide whole numbers by 1 and 2 digit numbers. So our success criteria are quite simple today. It's knowing when to use a calculator, what situations you should use one, recognizing the dividend and the divisor. So what's the number that we are dividing and how many pieces we're dividing it into. So the divisor is the number that does all the work. Correctly entering the number sentence into a calculator is nice and simple. And lastly, doing a common sense check to make sure that our answer that we've got on the calculator is actually correct. We haven't made any errors along the way. Okay, let's firstly think about situations when to use a calculator. Now, there are a lot of different situations when using a calculator is better than using a written or mental strategy. It's not lazy or you're not good at maths if you use a calculator to solve problems. There is a time and place for it. In a test where you're asked to use a written or a mental strategy, then yes, that wouldn't be a situation to use a calculator. But there are lots of other times when knowing how to use a calculator for division or multiplication or other types of operations is either necessary or it's the better way to go. So firstly, I want you to think about using it to check an answer that you've obtained using a written or mental strategy. So you've done the bus stop method, you've got your answer, you can use a calculator to check that your answer is correct. Now, there is a small condition on this, that your answer on a calculator on the default setting is going to be a decimal remainder. It won't be a whole number remainder like R equals, and it won't be a fraction remainder. With a scientific calculator, you can actually program it so you get those types of remainders, but the standard, the default remainder you'll get is a decimal remainder. So that's one thing to keep in mind. Other situations you might want to use a calculator is when you don't have a lot of time, you're kind of on the go, you need to quickly give somebody an answer. Where there are large numbers involved, where using the bus stop method, the longer the number is, the greater the likelihood of making an error. So having a calculator with a large number kind of makes sense. Also, in primary school, we only teach you to divide numbers using the written and mental strategy by a single digit divisor. So like 372 divided by 6 or 481 divided by 9, never a 2-digit divisor. Now, some people know how to use long division, and that's great, but it's not something we teach in primary school. Generally speaking, when you've got a divisor that's 2 digits or larger, it's probably a lot quicker and more efficient to use a calculator to solve that problem. Another situation is where you've got a lot of different calculations to do, so you don't really have the time or the energy to do a whole lot of written and mental strategies, so it just makes more sense to use a calculator there. If you need to be precise as well, so it's a lot easier and quicker to double check an answer on a calculator, and we'll look at it in a moment, than it is to have to, particularly when you've got lots of different calculations, then to go through each of them and go, okay, have I done this right? Have I done this right? And lastly, if you want an answer as a decimal, then a calculator is kind of a no-brainer as well. So there are situations when to use a calculator. I thought it's a good idea just to mention them and sort of bring it up here. Particularly this first one, it's the main one I want you to think about, is using it to check your answer with a written or mental strategy. So using a calculator. Now it might seem quite simple. I'm going to go through it, but there are a few pitfalls, a few mistakes you can make when you're using a calculator. So let's have a look at them. So firstly, I want to enter my number sentence, 2,275, 6 up that 7, divided by 3 equals, and that's what I'm going to enter into my calculator. So I'm putting, actually the first thing I should mention, before you do any calculations, when you're starting a fresh calculation, it's a good idea to press the C button. That clears anything that you've done in the past and make sure it doesn't kind of corrupt this number sentence. So press the C button first, then enter your numbers. So 2275 divided by, sorry, my divide button, 3, then my equals number, equals symbol I should say, and then it gives me my answer. Now, that's all good and well, it's given us our answer. The first thing you need to do though is do a few common sense checks. So don't always blindly trust what you get in the calculator is going to be the right answer. Don't just be like, well, the calculator says it, therefore it's right. There is a possibility that you might have made an error. You might have entered a wrong digit, or you might have accidentally hit one of these other operations. So here we're looking at two whole numbers, and this first one here is larger than the divisor. Yep, the dividend is larger than the divisor. Therefore, my answer, my quotient, needs to be smaller than this original number. If it's larger, it means that I've hit one of these other operations or another function here. So this happens to me a lot. Sometimes my finger accidentally slips and I hit the times symbol, or I might mistake the subtract symbol for the division symbol and accidentally get the wrong answer. So you want to do a common sense check. If this answer is larger than what you started with, then you've made an error. Secondly, I can estimate to see whether this answer is a reasonable answer. And I can do that by using inverse operations, knowing that multiplication is the opposite of division. So here I can kind of undo this number sentence by timesing 3 and 758. Now I can just do that mentally in my head. I can go, okay, well, let's look at this. So 3 times 700, that's going to be 2,100. Okay, it seems like we're in the same ballpark. 50 times 3 is 150, so we're up to 2,250, so it seems quite reasonable. The other way you can do it as well is just to reverse the operation. So here I've got my answer. I divided this number by 3, so I can just do the reverse. I can actually times this by 3, and it should give me my original dividend, the original number that I put in that I wanted to divide. So that's also a really quick way of checking that you've done the right thing and you haven't entered one of these other symbols. So always do a common sense check. Don't just blindly trust what you've put into the calculator straight away. You might want to enter it again just to double check as well. It is quicker than doing a written strategy, and it's a lot quicker to check. So make sure you always check what the output is from the calculator. So here are those tips for using a calculator just in some dot points. Tap the C button to clear at the beginning. Enter the digits and symbols like a normal division number sentence. Check that the number is smaller than what you started with. That's a real dead giveaway. Estimate your answer and compare with the calculator answer. So you can estimate it 2 ways. You can find the answer and multiply it by 3 using inverse operations, or you can sort of in your mind go, well, okay, wait, I've got 2,200 divided by 3. Well, I know that 221 divided by 3 is 7. So here I've got 2,100 divided by 3 is going to be like maybe 700. So you can use an estimate to help see whether your answer is reasonable. And the last one, which is probably the most simple, is just to re-enter the number sentence to double check. It doesn't take a lot of time to use a calculator to enter that again. You always want to make sure that what the answer you're getting out of a calculator is the right one. Now that we've looked at using a calculator to check our answers to division problems, what you might like to do is to go over your answers from yesterday where you had a remainder as a decimal and use a calculator just to double check that you had the right answer there. I could have given you a whole lot of number sentences to solve with a calculator today, but I thought that'd be rather boring. I thought a more interesting approach would be to give you some word problems involving averages and using a calculator to solve them. So let's look at this first problem. An adult giant panda eats approximately 5,475 kilograms or 5.75 tons of bamboo a year. How much bamboo do they eat on average? Firstly in a day and then in a week. So here I want to find out how much, this is how much it eats, giant panda eats in a year. So that's going to be my dividend. So I can write a number sentence for this. Grab my pen. 5,475. And I want to find out how much it eats in a day. Well, I know there are 365 days in a standard year, so not in a leap year. So we're just going to go with a standard year. So I'm going to do divide and 365. Enter that into my calculator and it'll give me my answer. Here I want to find out how much it eats on average in a week. Now when I say on average, a panda, or like anything, any person or animal, is going to eat different amounts on different days. Some days it might be extra hungry, some days not so much. So instead of kind of having like data that's kind of like this, having an average kind of flattens it out. So it spaces it out evenly so that each day it's eating the same amount. Now that's not the reality, but it kind of gives us what we call the average. So it's somewhere kind of in the middle roughly of how much bamboo it's eating in a day. So I want to find out how much it eats in a week. Well, there's two different approaches here. I could multiply the answer here by 7 because I know there are 7 days in a week. Otherwise, I could put my dividend here again, which is 5,700. So 5,475 divided by, and I know there are 52 weeks in a year, and I'd enter that into my calculator and it'd give me my answer. So that's how you find an average using division. So first we have our total amount here. Now sometimes with an average you'll need to add up a whole lot of different numbers to get your total. Then you divide it by whatever your divisor is. So here I'm dividing it by days in a year, which is there's 365 days in a year. Here I'm dividing it by weeks in a year, and there's 52 weeks in a year, so 52 is my divisor there. Here we've got another word problem, and I've included this on your worksheet as well, just as an example. So 140,000 Big Macs are sold every day in Australia. What is the average number of Big Macs eaten in Australia in an hour? Well, I've got my total number here, which is 140,000. Now, usually you wouldn't put a comma there. That's just kind of my old school approach there. It makes it easier for me, but yeah, it's not really good practice these days. And what is the average number of Big Macs eaten in an hour? Well, I know there are 24 hours in a day, and this is the total for a day. So I'm going to divide this number by 24. I punch that into my calculator and it will give me my answer. So here, this 24 is my divisor. That's how many parts I'm splitting it into. And this number here is my total. Again, this will give me the average number of Big Macs because I imagine people eat Big Macs more at lunch and dinner time rather than at maybe, for breakfast, like 6 a.m. in the morning. People generally probably not eating a lot of Big Macs then. So I grab the total and then I divide it by 24 to find out how many Big Macs on average are eaten in an hour in Australia. Okay, so to sum up, here are some of our main ideas. While we learn written strategies, there's a time and place for using calculators. So please don't feel like you're cheating or that you're less of a mathematician because you're using a calculator. There's a time and place for using calculators. And that time and place is today, so you'll be doing some of that today. Always do a common sense check with your calculator by estimating, by either using an inverse operation, making sure that your answer is smaller than the number you started with. Recognizing that the default setting on a calculator will give you your answer as a decimal. So don't expect to have a R equals or a fraction amount. Now you can do that with a scientific calculator. If you know how to do that, that's great. But a standard default calculator, either on a phone or just the ones we use in school or on a computer, will give you your answer as a decimal. And lastly, for finding an average, now this isn't really the focus for today, but I thought it'd be more interesting. You get the total number that you're dividing, so you might need to add those up. Then you divide it by whatever the question is asking you, whether it's asking you for days, so days in a year, 365, weeks in a year, it might be years over a certain amount of time, it might be number of people, dividing it by, we've got, I don't know, 500 pencils and we're dividing it between students at Rydalmere, so we might divide that by however many students are at Rydalmere, and that would give us our answer. Okay, so thank you very much, guys. I'll see you in lesson 3 for tomorrow. Bye. Hi everyone, welcome to your maths for week 4, lesson 3 for year 5. Okay, so on Monday we looked at using written and mental strategies to solve division problems, and Tuesday we looked at calculator skills to solve division problems, and today we're bringing it all together and looking at using different mental, written, and digital strategies or calculator strategies to solve division word problems. So to do that correctly, you need to be able to recognize when to use division to solve a word problem. So not all word problems obviously are division problems. So being able to identify when to use division and when to use another operation. Where it is a division problem, recognizing what the dividend is, that's the number you want to divide up, and what the divisor is, that's the number of groups you're splitting it into, or basically the number that's doing all the work. And using an appropriate strategy to calculate the answer. So choosing which one's more appropriate, whether it's a mental or a written or a calculator strategy. And finally, obviously with all word problems, making sure you answer the question. Okay, let's get started. Okay, so let's get started on our first word problem. Now I'm going to go through 5 of these today, and they're kind of different examples of ones you'll encounter in your activities for today. So firstly, a shipping company splits 7,630 crates evenly between 5 shipping containers. How many crates are put into each container? So I could use my cube strategy to solve this because that is one of our strategies we can use for word problems. It's quite a short word problem, but I'm going to do that anyway. So cubes, let's write it here, C-U-B-E-S. Now I'm just going to do this for the first one. Some of you might already know what the answer is or might know what the number sentence is going to be, but I'm just going to demonstrate the cube strategy just as a reminder. Some people might still like to use it, which is excellent. If not, that's totally up to you. Okay, so C stands for circling the numbers. So we've got 7,630 and 5. No other numbers in there. Now also make sure you look out for any numbers that might be written as words as well, because sometimes that can happen. Then I'm going to go to U, which is underline the question. And then B is box keywords. Now, a shipping company splits so many crates evenly. Well, splits, that's an operation, it's doing something. So I'm going to box that as best as I can. And I also like this word evenly as well. It seems like a keyword. It's not just splitting 500 crates over here and 200 crates over there. Each container has the same number of crates. Okay, so I'm going to go to E now. So I've done these ones. Let's tick them off. I'm going to E for evaluate. So this is where I need to figure out, well, evaluate and draw. I'm not going to draw it. It's quite a lot of containers and boxes, crates, I should say. So I'm just going to think about what kind of operation I need to use for this. Is it an addition, a subtraction, a multiplication, or division? Well, I can look at my keywords here. And I know that splitting evenly is what we do with division. We're splitting into equal groups or equal amounts. And the number that I'm going to be splitting is this number of crates. So I'm starting off with 7,630 crates, and I imagine splitting them into 5 different containers. Yep, so I'm doing a division problem, so I write that in my number sentence. Even if you know the answer to it straight away, it's always really good practice for a word problem to write the number sentence to show you're working out. And divided by 5. So this is my dividend, that's the number I'm dividing, and this is the divisor, that's how many groups I'm splitting it into. Now, I need to decide what sort of strategy I'm going to use here, whether I'm going to use a mental strategy, or I'm going to use a written strategy, or I'm going to use a calculator. Now, today I'm just going to do the bus stop method because I can show it on the screen easier. So I'm going to put my dividend down here and my divisor at the front. So 5 goes into 7 once with 2 left over. Now that becomes 26. 5 goes into 26 5 times because 5 times 5 is 25, sorry, with 1 left over. 5 into 13 goes twice because 2 times 5 is 10, with 3 left over, and 5 goes into 36 times because 5 times 6 is 30, and it actually goes evenly. There's no remainder. So the amount that goes into each container is 1,526. Let's move on to our second word problem now. Okay, word problem number 2. So we've got 312 ninja assemble. They agree to form groups of 8 ninja each. How many groups are formed? So this is my total amount of ninja. There's no more coming along, 312. And here I appear to be splitting them or dividing them again because we're talking about equal groups. But this time, instead of splitting them into 8 groups, each of the groups has 8 in it. So it's kind of the reverse, not the reverse, but it's slightly different to the last problem. And this is the 2 different ways of thinking about division. So you can think about how many are in each group, like the first problem where we knew how many groups there were, we just wanted to know how many were in each group, or for this one, how many 8s are there in 312. So it's 2 ways of thinking about division. So I'm going to write my number sentence now. I'm not going to do cube strategy because I did that for the last one. So I'm going to write my dividend 312, division symbol, 8 equals, and I'm going to use our bus stop method for this. 312 down here, and the divisor at the front. 31, so I'm going to join this together. 8 can't go into 3, so it becomes 31. 3 times 8 is 24. And now I know that 4 times 8 is 32, so this is going to be 3, and it's going to have a remainder of 7. And that becomes 72 now because I've taken 7 10s and added them to these 2 1s, so now it's 72. 8 into 72, or 72 divided by 8. Well, I know that 8 times 9 is 72, so the answer is 9. So here, how many groups have they formed? They've formed 39 groups. Okay, let's move on to our next one. Okay, now here is our third word problem. 250 people turn up to a nightclub. Only 3/5 of them are allowed inside. How many people are allowed inside? So I've got 250 is my total. Yep, there's no more coming along, but only 3/5 of them are allowed inside. So I know that a certain proportion of these people are allowed inside. Now with a problem involving a fraction, we know that fractions and division are related. So let's say I write 3/5 like this. I know that this 5 down the bottom represents how many parts of one whole. So the one whole would have been split into 5 parts, and then we're referring to 3 of those parts there. Yep. So let's think about 250. 250 has been split into 5 equal parts, and 3 of those equal parts, or 3 of those equal groups, are allowed into the nightclub. So let's write our total amount here, 250. And I know I want to split it into 5 equal parts. Just make our division symbol there, 5. So 250 divided by 5. Now I can do this in my head because I know that 25 divided by 5 is 5. And also, I just got a 0 here, so I just have to tack on the 0. Yep, that's simple. If you needed to use the bus stop method for that, that's okay, but sometimes you can just do these things mentally. So in that case, I could just do it mentally nice and quickly, but I'm not finished yet because 50 tells me what 1/5 is. Yeah, 1/5 equals 50. But I want to find out what 3/5 is. So now I get 50 and I multiply it by 3. It'll tell me 1/50 people. So 3/5 of 250 is 150, 150. So it's a 2-step problem in that situation and 2 different operations. We've got division to start off with, and then we have to multiply one of those parts by 3 there. Okay, word problem number 4. So a shipping company splits a shipment of boxes across 10 shipping containers so that each container holds 670 boxes. How many boxes are in the shipment? Okay, well, this seems very similar to our first problem, doesn't it? Yep, we've got some boxes, they're being split across containers. I've got the word split here. Oh, must be a division problem. Well, in fact, even though it seems like it's a division problem because it's got this word split, it's actually a multiplication problem, and I'll show you why. Firstly, even though these keywords in word problems can be helpful, they can also sometimes be misleading if we don't have a proper understanding of what's happening in the word problem. So here, I'm going to draw a little picture. So we've got our 10 shipping containers. Now, I'm not going to do all 10 of them because that will take forever. Let's say let's do 4. Yep. And each of them has 670 boxes inside. Yep. And I want to find out how many boxes are in the shipment. So the shipment is the total amount. Yep. The question is, say, how many boxes are in total? I thought that might be a bit of a dead giveaway. So here, 670 plus 670 plus 670. I could use addition, but I know that multiplication is repeated addition. Yep. So here I've got 670. I'm going to add that in times. So I'm going to multiply it by 10. And I know when I'm multiplying by tens or by hundreds or by thousands, I just need to add however many zeros there are. So here I've got 1 0. So I just need to add that to my original number. And so I end up with 6,700 boxes. Now, you might be asking, well, aren't we doing division this week? And why is this problem in here? Today, you'll have a few word problems that don't involve division, or they might involve division for a part of it, but then also involve multiplication or subtraction or addition. I really want you to focus on knowing those situations when to use division and when not to use division, because in the real world or in real life problems, you don't have a question there telling you or kind of giving you keywords as to what you need to do. You need to decide what's the right operation now. So today there's a few in there that might be addition problems, might be subtraction problems. So you need to think, do I actually understand what's going on in this problem? And here's our last word problem for today, and it revolves around value for money. So which of these offers here is better value for money? Now you'll see that they are different amounts. This is 100 grams and this is 600 grams. What we want to know is whether if I buy 6 of these 100 gram packets, whether it's going to cost the same amount as this second offer down here or it's going to be more. So one way of solving this problem is to multiply this by 6, and that way I can get 600 grams. Another way, which you'll see in the supermarkets as well, so sometimes these word problems, they were a bit more relevant a couple of decades ago, but more recently now, when you go to the supermarket, you'll actually see the price listed underneath the product. So it'll have its normal price, then it'll say how much it costs, for example, per 100 mils or per 100 grams. That's a good way of comparing prices. So you can actually easily compare between different products or the same product, but different brands to see which one's cheaper. So here I can multiply it by 6, but also with this one here, I can divide it by 6. Yep, so I can find out, well, how much is 100 grams of candy of this brand going to cost compared to this one? So what I might do quickly, I'll just put that into a calculator. Divided by 600. Oh, sorry. So it's got my number sentence. Sorry, I even got that wrong. 1090 divided by 6. That's going to give me how much per 100 grams. So 1090 divided by 6. It's going to be $1.81.6, and I'm going to round that up, so it's $1.82. Yep. So for 100 grams down here, it's going to cost $1.82. $1.82. And for this one, 100 grams is $1.95. So clearly this one here is the better value. Now, the value here is it's not a huge amount. We're talking like 13 cents. It's not really a huge amount, but when you're talking about bigger products or bigger amounts, then the value, and it actually does matter. I thought we'd stick with small numbers today to make it just a bit easier. So I'll rub all this out and we can try and have a go at this one here. So now this one's slightly more complicated. We've got 200 mils of soda and 700 mils of soda. So what we want to figure out is an easy way to do this is to go, well, let's make it per 100 mils. And I'm going to divide them by, this one I'm going to divide by 2. So it'll be 195 divided by 2. And here it's going to be 7 divided by 2. Oh, sorry, 7 divided by 7. Because I've got 700 mils here, so I'm dividing it by 7. And here I've got 200 mils, so I'm dividing it by 2. So that's going to be easy, nice and easy. 7 divided by 7 is 1. 195 divided by 2 is 97, sorry, 0.97. And it's actually 0.975. So I can just round that to 0.98 because there are only 2 decimal places with currency. So 0.98. So this one here is 2 cents cheaper. So if you really want to save your money on your soda, then this one here is a better deal. Okay, so just to wrap up, here are some of the main ideas from today's lesson. So splitting or sharing problems typically involve division. So things where it's sharing equally into groups or splitting equally into groups, it's more than likely a division problem, but also be mindful that sometimes those words can be not used to deceive you or trick you, but it might actually require another operation. So you do need to think critically about it. The dividend is a number that is being divided. So that's our the first number in our number sentence. The divisor is either the number of groups that we're making or the number in each group. So remember the example with the shipping containers. It can be the number of containers it's going into, or it can be the number in each container. Just depends what the question's asking. Problems involving fractions of a whole typically involve division. So we had that one with 3/5. First, we had to divide the whole number by 5 and then multiply it by 3. And lastly, to find which is better value or better value for money of different amounts, try to get them down to a common amount. So you might want to divide so that you have the same amount and then the cost for that amount. So for example, with our 100 grams of candy, we brought that second price down to 100 grams. And same with the soda example, we divided each of those so we had 100 mils and we could compare the prices there. We're comparing the same amount, and that way we can find out which one is better value. Okay guys, thanks for listening. I'll see you in lesson 4, which is our last video lesson for the week. Welcome to your last video maths lesson for this week, lesson 4, Thursday for year 5. Today, what we're going to be doing is solving division word problems involving remainders. And more specifically, we're looking at situations where we need to round up an answer because there is a remainder, and also correctly choosing whether to represent the remainder as a remainder, like a whole number remainder, as a fraction, or as a decimal. Let's look at rounding up an answer first. So 37 people are stranded at sea. A rescue chopper can only carry 5 rescued passengers at a time. How many trips will it need to make to rescue all the people? So there's different ways of approaching this. You might go, okay, well, each time it's traveling out there to rescue people, it can pick up 5. So this is my first group of people. Then I'm going to add another group of people, another 5, and so on, until you get to 35. Oh, not so good with the pluses. 1, 2, 3, 4, 5, 6, 7. Yep, so that gets me 35. And then I've got another 2 people to go out. Now this last trip, it's not going to have 5 passengers on it. It's only going to have 2 passengers. But I still need to make the trip, otherwise 2 people are still going to be stranded at sea. So it's actually going to be, we're going to add 2 here, but this is still the total number of trips. 1, 2, 3, 4, 5, 6, 7, 8. So it needs to make 8 trips. The other way to do this, the inverse, so this is the repeated addition, or you might even use multiplication. You might go 7 times 5 equals 35, and then you've got the other 2 people to pick up, so you need to add 1 more on, so you end up with 8. The inverse, or the opposite of that, is division, because we know division and multiplication are inverse operations, opposites of one another. So we've got 37 divided by 5. Yep. So here what we're trying to figure out, let me just write that down, 37 divided by 5 gives us 7 remainder 2. But the 7 remainder 2 here, this doesn't answer the question. I can't make 7 remainder 2 trips. Yeah. The remainder 2 here is representing the number of people. It's not representing the number of trips. So what I need to think about, well, I've got 2 people left over here. So instead of making 7 trips, I need to make 8 trips to get them all. So this is where we are rounding up the answer. We're going, well, actually, 7 remainder 2, like 7 trips is not enough. Yep, I need to round it up to 8. Now there's going to be 3 seats spare on that helicopter. That's totally fine. It still answers the question. 8 trips will rescue everybody. Okay, here's another example. Mrs. Martelli is having a birthday party, pre-COVID of course. She wants to invite 235 guests. A large birthday cake has 60 slices. How many cakes will she need to buy to make sure each guest receives 1 slice each? So in this situation, we've got a large birthday cake has 60 slices, and we've got to feed 235 people. So again, we could do that similar strategy of 60 plus 60 plus 60. The other thing we could do is we could do 235 divided by 60. And you can just do this in your calculator if you like. 235 divided by 60. Actually, it gives me 3.916. Yep. Now, if I go to the cake shop, I can't go, oh, can I have 3 cakes and 0.9 of a cake as well, so 90% of 1 cake. Generally, cakes are sold as a whole item. So here, if we want to make sure everybody gets fed, we're going to actually need to round this number up to 4. So you should need to buy 4 large birthday cakes to make sure everybody receives 1 slice each. Now there will be some left over, but she can't just buy 3 and go, oh, well, sorry, the rest won't have any. Everybody wants to get 1 slice. She'll need to buy 4. So that's where another situation where we're rounding up the answer to make sure that we answer the question that everybody is satisfied. And the last slide for today is about answering with the right remainder. So here we've got 3 different situations, and we're going to look at what's probably the best way of representing the remainder. So we know that with remainders, we can record them as whole numbers, as r equals, as a fraction, or as a decimal. But with word problems, we need to think carefully about what kind of remainder, or how we're going to represent the remainder as an answer to that question. So here we've got 27 students split evenly between 5 classes. So I know that my answer could be 3 things. It could be 5 remainder 2, because 5 times 5 is 25, plus 2 is 27. It could be 5 and 2/5, or it could be 5.4. Yeah. Now, in this situation, which one do you think is the most appropriate answer to this question? Yeah, it's going to be this first one here, because this means there are 5 students going to each of the classes, and there are 2 students left over who haven't been able to be split evenly into those 5 classes, so they'll probably have to be tacked onto another class. Here, yes, we've got the 5 students, but we can't have 2/5 of one student going to a class. We can't split somebody up into fifths and send part of them to one class and one to the other, like not ethically anyway. And 5.4, it really doesn't make any sense either. It's basically the same as a fraction here. So here, this whole number answer, whole number remainder makes the most sense because we're dealing with whole people here. Let's look at this one here. So B, we've got 13 cupcakes split between 3 friends. So my one way of representing is 4 remainder 1, because I know 4 times 3 is 12, plus 1 more is 13, so I've got a remainder of 1. Another way of doing it is to say 4 remainder 1, and we're dividing it by 3. So here's representing it as a fraction, 4 1/3, and also as a decimal. Now, anytime you see 1/3 like this, the decimal version is always going to be 0.3 recurring, so it's 0.3333, etc. So here, which one do we think is the most appropriate answer, splitting cakes between 3 people? Now, this one doesn't really make a lot of sense. 4.33333. Yeah, if you didn't know that that is the same as 1/3, it doesn't really make any sense. There's no point of representing it that way. This first one, yep, each friend could get 4 cupcakes, and there could just be 1 left over that nobody gets. But here it kind of makes better sense to do 4 1/3, because we know, unlike people, we can cut them into thirds. So we've got 4 whole cupcakes, and then we can cut the last cupcake into thirds, and each friend gets a third. That way there's no wastage, everybody gets a cupcake. So in this situation, this is probably the most appropriate way of representing the remainder. Lastly, we have dollar amount here, so 77.55 split between 4 friends. Now to do this, I haven't even solved this one yet, so 77.55 now. Immediately, when I'm dealing with money, I generally don't want to be involving fractions. Yeah, it's not going to be 4 1/3, for example. It's actually really confusing that way. With money, we're generally concerned with decimal values, yeah, because money is represented as a decimal, so my answer should be a decimal amount. So here, I'm not even going to bother doing it the other ways. 7.55, I'm actually going to punch it into a calculator. So my answer would be, let's just rub that out, because I'm not even going to do bus stop method today for that. It's my choice. So my answer is going to be $19.387 and so on. Now, because a decimal amount always has 2 decimal places, I need to round it to 2 decimal places unless I'm rounding it to the dollar. So here it'll round up. It'll be 39. And actually in Australia, because we don't have 1 cent and 2 cent coins anymore, you could even round that to 40 cents. But the thing is, you'd be going to short 3 cents, so I'd probably just leave it as 0.39. Same with metric measurements, so things like milliliters, grams, kilograms, they're all parts of 100, so for example here, or thousands. So it's usually best to represent them as a decimal. Yep, so for example here we've got 460 milliliters of milk split between 7 kittens. I'm really struggling for examples here. 7, actually that's, so they're going to get, now this, I don't know why you'd split it this way, but just what's being asked of us. So 4 here, sorry, 65.714 mils. And here you could probably round it up or even round it up to the closest mil because this is such a small amount that there's no real way you can kind of measure that. So I'd probably just say about 66 mils. And there'll always be a margin of error if you're measuring it anyway. Yep, but here it makes more sense to represent it as a decimal. You don't want to have 65 and 1/3 of a mil, for example. It doesn't really, or 1/4 of a mil. It doesn't really make any sense. So money and metric measurements use decimal places. Where you've got something that can be split up into fractions, like a cake or food or an area, you might want to use a fraction. And where you can't actually split the remainder up, typically if you're dealing with like live animals or with people, you want to keep that remainder as a whole number. So that's where you use R, the remainder R equals. And just to wrap up from today, here are the main ideas. So firstly, there are situations where you'll need to round up your answer to answer the question appropriately. So for example, with our helicopter example, with the cake example, making sure that there's enough of either enough helicopter trips or enough cake to feed everybody, even though there's going to be some left over, you still need to make sure you're answering the question appropriately. So in those situations, you would round up your answer. Make sure that your remainder makes sense. So when we're dealing with people, for example, as a classic case, you can't halve people and share them between rooms or between groups. So consider recording your answer as R equals, as a whole number remainder like this, R equals. If you have food that can be split or some other material that can be split into pieces or amounts, then consider using a fraction remainder to make sure there's no wastage. So if we've got maybe pieces of paper and I end up with one piece of paper and there's 3 people, I can probably cut that up into 3 pieces, depending on what the paper is being used for, of course. So make sure it's appropriate to the question. And lastly, remainders involving money or metric measurements are best represented as decimals. That's because, particularly with money, money is already in decimal places. So you may as well record your remainder as a decimal. It makes it a lot easier to figure out how much money you're actually getting. Okay, thank you for bearing with me, everybody. I hope you have a great week, and we'll see you next week. All right, bye.